Hello friends, today I want us to try and use Proteus to practice some amplitude modulation. There are a series of methods we could use, but this is the simplest, I think. So all we need is a carrier signal, an information signal, and then a modulator. Okay, and Proteus has this signal generator that can also be used as a modulator because it has modulation functions inbuilt in it. So when we pick this signal generator from the virtual instruments, we can pick an oscilloscope so we can monitor the waveforms. So let's connect channel A of the oscilloscope to the positive of the signal generator, and we can pick a ground from the terminals section. Yeah. And we can form something as simple like this. So let's look at how our wave from the signal generator would look like, which will be our carrier wave in the future. Okay, so this is when you run your simulation, the virtual instruments actually pops up there. So there is your control knobs for the signal generator. So we can set frequency and then the amplitude of our wave. So I've currently set the frequency to 10K. I think when you use higher frequencies, it takes much of your computing power, so you can stick with something around 10K and to be fine. Then let's pick an amplitude of let's say 4. Now you can see that as I increase the amplitude, you see the wave increasing in height on the oscilloscope. So we can see it better by adjusting the wave per division. Now there's a 4-channel oscilloscope, so we have 4 different control sections for the volts per division. So we can increase the one for the yellow one, which is channel A, so we can see it better. We can turn off the rest since we are not using it. Okay, so you can use the vertical position to probably position in the center, and we can use the second division to see our wave well. Now you can see that the amplitudes of the waves are all equal at both sides, so this could be our carrier wave. Let's try and get an information signal, probably from a sine generator, so that we'll have something similar to what we have been seeing in books. Okay. So let's try and edit the properties. So let's set the amplitude of the information to be around 2 and then 2 volts and the frequency 50 hertz. Okay. To see it well, we could connect channel B to the information signal so we can see it well. So there we have it. Our information signal is the blue, and then our carrier is the yellow. That has been modulated. So now the yellow is our modulated wave or signal, if you want to put it that way. Now I'm just trying to adjust so you get a proper view. Okay, so we can take a one shot. Okay, you can take a one shot to see it well. Very good. Now we can see here that at first, when this yellow was just our carrier, the ends were the amplitudes were all in line and having the same length. But we see that right now the amplitude is changing, okay, based on the amplitude of the information signal, which is the blue one. So the blue has been used to modulate the yellow, and now the yellow is the modulated signal. And as you can see, the blue fits on it perfectly. Okay. Now, it means that when we send this wave to the other side, the amplitudes can be read, and then we can construct this blue signal back. Now there is 50% modulation index because I have my carrier to be around 4 volts, and then our information is 2 volts. So there's 50% modulation index. So let's try 100% modulation index. Let's change our information signal to 4, like our carrier signal, and then let's see. Okay, auto capture. Beautiful. So this is 100% modulation. Okay, so it seems all that we see now are the sidebands fully modulated by the information signal. This blue we are seeing, it fits perfectly, and it seems not to be like any carrier in the middle between the sidebands. So there's 100% modulation index. Okay, and then let's overmodulate. So let's once again increase our information signal to, let's say, 6 volts, and then we have triplets form, like snapshots. Okay, triplets forming an inverted form of the waveform in between, and this characterizes over modulation more than 100%. So there is one of the easy ways to use Proteus to perform simple amplitude modulation. So I hope you try different modulation, amplitudes to get different modulation index. You can also change the frequency, and later, maybe in our next video, we'll try and perform or continue this using an actual audio file. For this example, we are using a sinusoidal wave, so we see the edges to follow the pattern of the sinusoidal wave, but we'll try it with an audio file and see how irregular the ends will be according to the amplitude of the audio file. Okay, so have a wonderful time. Subscribe to this channel and see you later. Bye bye.